back to my coverage of CES 2026. In my last video, I rushed from Las Vegas Harry Reid International Airport to NVIDIA's event at the Fontainebleau. You can see my full overview of the NVIDIA keynote and exhibit on the NavFile YouTube channel. Now I'm covering my journey from the Fontainebleau to the AMD CES 2026 keynote at the Palazzo Ballroom in the Venetian Convention Center. This was still day one, January 5th, 2026. I departed Orlando at 10:14 a.m. Eastern Time, and the AMD keynote ended just after 8:30 p.m. Pacific Time, 11:30 p.m. Eastern. It was a long day. After calculating my route, I decided to walk from the Fontainebleau to the Venetian by the way of the West Hall of the Las Vegas Convention Center and Las Vegas Boulevard. It's a nice walk that takes you past Resorts World and the Wynn. Las Vegas hotels and casinos are essentially a maze, so if you're on a deadline, I highly recommend researching your route in advance. Use the resort PDF maps to determine exactly where you need to go. Signage inside the casinos isn't always the clearest, so it's best to know your path before heading out. I'm even considering putting together a master map of the Las Vegas Strip casinos that can be easily referenced. Once again, I was in a bit of a rush to make sure I arrived at the Venetian early enough to secure a spot in line for the headline AMD keynote. This keynote was actually the official opening keynote for CES 2026, since NVIDIA Live was not part of the official CES schedule. NVIDIA announced its live events later than usual this year, as it appeared the company was still deciding what type of presence it would have at CES 2026. Last year, NVIDIA delivered the opening keynote at Michelob Ultra Arena at Mandalay Bay, a much larger venue. I arrived very early for that one and was among the first group inside the arena. As you'll see, I made it to the AMD event just in time. The line was extremely long by the time I arrived. I ended up in one of the last groups to receive an entry wristband. I'm not sure everyone in the line to the left on the video there made it in. The Venetian lists the Palazzo Ballroom theater seating capacity at 7,500 people. As you'll see throughout my CES 2026 coverage, the Palazzo Ballroom hosted many of the major keynotes. I was glad to get in and secure a seat towards the back corner of the ballroom. The only downside was that it was packed, and with flat floor seating, it was difficult to see the stage clearly from that distance. Still, I was happy to be there and to hear insights from AMD CEO Dr. Lisa Su in person for the first time. To give you a first-person perspective of the keynote and highlight the key moments, I'll combine my footage with portions of the live stream. I'll add commentary and context to the segments I found most important. In a multi-decade CES tradition, Gary Shapiro, CEO of the Consumer Technology Association, introduced Dr. Lisa Su.
And a leader whose work continues to shape the very trajectory of modern computing. Ladies and gentlemen, please join me in welcoming to the stage Chair and CEO of AMD, Dr. Lisa Su.
Thank you, Gary. Thank you. All right, what an audience. How are you guys doing tonight? That sounds wonderful.
In a future video, I'll explain how I ended up speaking with Gary on day 3 of the convention. Lisa Su then took the stage and introduced the evening's themes. She began by discussing the remarkable growth in AI usage.
And at AMD, we're building the compute foundation to make that future real for every company and for every person. Now, since the launch of ChatGPT a few years ago, I'm sure we all remember the first time we tried it. We've gone from 1 million people using AI to now more than 1 billion active users. This is just an incredible ramp. It took the internet decades to reach that same milestone. Now, what we are projecting is even more amazing. We see the adoption of AI growing to over 5 billion active users as AI truly becomes indispensable to every part of our lives, just like the cell phone and the internet of today. Now, the foundation of AI is compute. With all of that user growth, we have seen a huge surge in demand in the global compute infrastructure, growing from about 1 ZetaFlop in 2022 to more than 100 ZetaFlops in 2025. Now, that sounds big. That's actually 100 times in just a few years. But what you're going to hear tonight from everyone is we don't have nearly enough compute for everything that we can possibly do. We have incredible innovation happening. Models are becoming much more capable. They're thinking and reasoning. They're making better decisions.
Moving from 1 ZetaFlop to 100 ZetaFlops in just 3 years is extraordinary. Lisa acknowledged the ongoing AI compute shortage and outlined how AMD plans to play a major role in closing that gap. Throughout the keynote, we saw that AMD has built a strong portfolio of AI and computing solutions to address market demand. The key question going forward is whether AMD can attract enough developers and enterprises to build on its GPU platform. We'll revisit that theme later.
Now, to enable this, you need AI in every compute platform. So what we're going to talk about tonight is the whole gamut. We're going to talk about the cloud, where it runs continuously, delivering intelligence globally. We're going to talk about PCs, where it helps us work smarter and personalize every experience that we have. And we're going to talk about the edge, where it powers machines that can make real-time decisions in the real world. AMD is the only company that has the full range of compute engines to make this vision a reality. You really need to have the right compute for each workload. And that means GPUs, that means CPUs, that means NPUs, that means custom accelerators. We have them all. And each of them can be tuned for the application to give you the best performance as well as the most cost-effective solution. So tonight, we're going to go on a journey. So you're going to go with me through several chapters as we showcase the latest AI innovations across cloud, PCs, healthcare, and much more.
AMD's portfolio is impressive. CPUs, GPUs, and everything in between. I picked up an HP AMD Ryzen AI Max laptop last holiday season, partly because of its benchmarks. AMD's full lineup, from edge devices to data center AI, shows its commitment to every level of AI computing.
So let's go ahead and start with the first chapter, which is the cloud. The cloud is really where the largest models are trained and where intelligence is delivered to billions of users in real time. For developers, the cloud gives them instant access to massive compute, the latest tools, and the ability to deploy and scale as use cases take off. The cloud is also where most of us experience AI today. So whether you're using ChatGPT or Gemini or Grok, or you're coding with copilots, all of these powerful models are running in the cloud. Now, today, AMD is powering AI at every level of the cloud. Every major cloud provider runs on AMD EPYC CPUs. And 8 of the top 10 AI companies use Instinct accelerators to power their most advanced models. And the demand for more compute is just continuing to go up. That's exactly why we built Helios, our next generation rack scale platform for the Yotta-scale AI era. Helios requires innovation at every single level: hardware, software, and systems. It starts with our engineering teams, who designed our next generation Instinct MI455 accelerators to deliver the largest generational performance increase we've ever achieved. MI455 GPUs are built using leading edge 2 nanometer and 3 nanometer process technologies and advanced 3D chiplet packaging with ultra-fast, high-bandwidth HBM4 memory. This is integrated into a compute tray with our EPYC CPUs and Pensando networking chips to create a tightly integrated platform. Each tray is then connected with high-speed ultra-accelerator link protocol tunneled over Ethernet, which enables the 72 GPUs in the rack to function as a single compute unit, And then from there, we connect thousands of Helios racks to build powerful AI clusters using industry-standard Ultra Ethernet NICs and Pensando programmable DPUs that can accelerate AI performance even more by offloading some of the tasks from the GPUs. Now, we are at CES. It is a little bit about show and tell. So I am proud to show you Helios right here in Vegas, the world's best AI rack. Is that beautiful or what? Now, for those of you who have not seen a rack before, let me tell you, Helios is a monster of a rack. This is no regular rack, okay? This is a double-wide design based on the OCP Open Rack Wide standard developed in collaboration with Meta. And it weighs nearly 7,000 pounds. So, Gary, it took us a bit to get it up here, just so you know. But we wanted to show you what is really powering all of this AI. It is actually more than 2 compact cars. Now, the way we've designed Helios was really working closely with our lead customers, and we chose this design so that we could optimize serviceability, manufacturability, and reliability for next-generation AI data centers. Now, let me show you a few other things. At the center of Helios is the compute tray. So let's take a closer look at what one of those trays look like. Now, I can tell you, I probably cannot lift this compute tray, so it had to come out. But let me just describe it a little bit. Each Helios compute tray includes 4 MI455 GPUs, and they're paired with the next-gen EPYC Venice CPU and Pensando networking chips. And all of this is liquid-cooled so that we can maximize performance. At the heart of Helios is our next-generation Instinct GPUs. And you guys have seen me hold up a lot of chips in my career. But today, I can tell you, I am genuinely excited to hold up this chip. So let me show you MI455X for the very first time. MI455 is the most advanced chip we've ever built. It's pretty darn big. It has 320 billion transistors, 70% more than MI355. It includes 12 2-nanometer and 3-nanometer compute and I/O chiplets, and 432 gigabytes of ultra-fast HBM4, all connected with our next-gen 3D chip stacking technology. So we put 4 of these into the compute trays up here. And then driving those GPUs is our next-generation EPYC CPU, codenamed Venice. Venice extends our leadership across every dimension that matters in the data center. More performance, better efficiency, and lower total cost of ownership. Now, let me show you Venice for the first time. I have to say, this is another beautiful chip. I do love our chips, so I can say that for sure. Venice is built with 2-nanometer process technology and features up to 256 of our newest high-performance Zen 6 cores. And the key here is we actually designed Venice to be the best AI CPU. We doubled the memory and GPU bandwidth from our prior generation, so Venice can feed MI455 with data at full speed, even at rack scale. So this is really about co-engineering. And we tie it all together with our 800 gig Ethernet Pensando Vulcano and Selena networking chips, delivering ultra-high bandwidth as well as ultra-low latency, so tens of thousands of Helios racks can scale across the data center. Now, just to give you a little bit of the scale of what this means, that means that each Helios rack has more than 18,000 CDNA 5 GPU compute units and more than 4,600 Zen 6 CPU cores, delivering up to 2.9 exaflops of performance. Each rack also includes 31 terabytes of HBM4 memory, an industry-leading 260 terabytes per second of scale-up bandwidth, and 43 terabytes per second of aggregate scale-out bandwidth to move data in and out incredibly fast. Suffice it to say, those numbers are big. When we launch Helios later this year, and I'm happy to say Helios is exactly on track to launch later this year, we expect it will set the new benchmark for AI performance. And to put this performance in context, just over 6 months ago, we launched MI355, and we delivered up to 3x more inference throughput versus the prior generation. And now with MI455, we're bending that curve further, delivering up to 10 times more performance across a wide range of models and workloads. That is game-changing. MI455 allows developers to build larger models, more capable agents, and more powerful applications.
The unveiling of the Helios rack was a major milestone. It plays a central role in AMD's effort to compete with NVIDIA's NVL72 rack-scale systems. Lisa highlighted AMD's partnership with Meta through the Open Compute project in developing Helios. This previewed a broader partnership announcement between the two companies. Just days before recording this, AMD announced a major agreement with Meta for 6 gigawatts of Instinct MI450 GPUs as part of the Helios rack-scale platform. It will be interesting to see how this develops over the year and whether AMD can maintain its momentum in cloud computing. Next, Lisa welcomed Greg Brockman, president and co-founder of OpenAI, to discuss how OpenAI is working to improve lives through artificial general intelligence.
Extremely happy to welcome Greg Brockman to the stage. Greg, it is so great to have you here. Thank you for being here.
And so just out of curiosity, how many people in the room are ChatGPT users?
That's pretty much the whole room,
Yes.
Greg, I would
Thank
just say.
you. I'm glad to hear it. But very importantly, how many of you have had an experience that was very key to your life or the life of a loved one, whether it's in healthcare, in helping manage a newborn, in any other walk of your life? And to me, that's the metric that we want to optimize. And that seeing that number go up and to the right has been something that has been really different over 2025, right? That we really moved from being just a text box that you ask a question, you get an answer, something very simple contained, to people really using it for very personal, very important things in their lives. And it's not just in personal lives, for healthcare and aspects like that. It's also in the enterprise, right? And really starting to bring models like Codex to be able to transform software engineering. And I think that this year we're really going to see enterprise agents really take off. We're seeing scientific discovery start to be really accelerated, whether it's developing novel math proofs.
Now, I would say, I think every single time I see you, you tell me you need more compute.
It's true. It's true.
It's almost like a broken record. Like you could just, just play the Greg wants more compute. Can you talk about just some of the things that you're seeing in the infrastructure, some of the bottlenecks, and where do you think we should be focusing as an industry?
Well, the why do we need more compute is the most important question, right? Which is really when the models are not that capable, right? And where we were in 2015, 2016, 2017, so forth, is that you basically just wanted to train a model and evaluate it, right? And maybe there'd be a very narrow task it'd be useful for. But as we've made this exponential progress on the models, then there's actually exponential utility to them. People want to bring it into their lives in a very scalable way. And I think that what we're seeing is as we move from you ask a question, you get an answer, to agentic workflows, where you ask the model to write some software for you, and it goes off for minutes or hours or soon even days. And you're not just operating one agent, you're operating a fleet of agents, right? You can have 10 different work streams all going at once on your behalf for a single developer. Right? And that it should be the case that you wake up in the morning, and this is the kind of thing we are going to build, by the way. And ChatGPT has taken items off your to-do list at home and at work. And that all of that's going to require that, that big graph that you had of how much compute the world's going to need. That's going to require far more compute than we have right now. Like, I would love to have a GPU running in the background for every single person in the world because I think it can deliver value for them. But that's billions of GPUs. No one has a plan to build that kind of scale. And so what we're really seeing is benefits in people's lives, right? We're seeing, for example, some of my favorite applications and some of the ones I think are the most important are in healthcare, right? That we actually see people's lives being saved through ChatGPT. Just over the holidays, one of my coworkers, that her husband had leg pain. They went to the hospital, they went to the ER, and they got it x-rayed, and the doctors are like, it's a pulled muscle, just wait it out, you'll be fine. They went home, it got a little bit worse, typed the symptoms into ChatGPT. ChatGPT said, go back to the ER, this could be a blood clot. And in fact, it was deep vein thrombosis in the leg, in addition to 2 blood clots on the lungs. And if they just waited it out, that would have been likely fatal. It's not a unique story. Fiji, our CEO of applications, who I work very closely with every day, ChatGPT literally saved her life too. Right? She was in the hospital for a kidney stone and had an infection. They were about to inject a antibiotic, and she said, "Wait just a moment." She asked ChatGPT whether that one was safe for her. ChatGPT, which has all of her medical history, said, "No, because you had this other infection 2 years ago, that could re-trigger it, and that could actually be life-threatening as well." And so she showed it to the doctor. The doctor's like, "Wait, what? You had this condition? I didn't know. I only had 5 minutes to review your medical history."
Yes. I completely agree, Greg. I mean, that's one of the things that we can always, all of us can use a helper.
Yes.
And that's really what we have here. Look, I mean, I think you've painted a vivid picture of why we need more compute, of what we can do with AI. I think we feel exactly the same way. Now, we've also done an incredible amount of work with your engineering teams. MI455 and Helios is actually, a lot of it is through some of the feedback from our engineering teams working closely together.
Greg emphasized science and healthcare as key areas where AI and ChatGPT can help solve complex problems. These sectors may ultimately see some of the most meaningful impact from AI, particularly in diagnosing complex conditions and delivering life-saving solutions.
One of the exciting AI companies using AMD and ROCm to power their models is Luma AI. Please join me in welcoming the Luma AI CEO and co-founder Amit Jain to the stage.
After OpenAI, Lisa invited Luma AI CEO Amit Jain to discuss the company's audio-visual multimodal AI model,
How are you? It's great
Ray
to have you
3.
here with us. You're doing some incredible work.
Most AI video and image models today, they're in early stages, and they're used to generate pixels. They're used to produce, pretty pictures. What is needed in the world are more intelligent models that combine audio, video, language, image all together. So at Luma, we are training these systems that simulate physics, causality, are able to go out, do research, call tools, and then finally render out the results in audio, video, image, text, whatever is appropriate for the information that you're trying to work with. In short, we are modeling and generating worlds. So as an example, let me show you some results from our latest model, Ray 3. By the way, Ray 3 is the world's first reasoning video model. So what it means is it actually is able to think first in pixels and latents and decide whether what it's about to generate is good. And it's also the world's first model that can generate in 4K and HDR. So please take a look.
When you close your eyes, what do you see? When we talk about reality, how do you know what is real? Or what is simply your imagination? Now open your eyes.
I could say, Amit, that looked pretty incredible. So tell us, how are customers using Ray 3 today?
So we are working with very large enterprises as well as individual creators across the spectrum. And we work with them in advertising, media, entertainment, and industries where, you want to tell your story. 2025 was the year when they started to deploy our models and experiment with them. And towards the end of it, we are seeing large-scale deployments where people are using our models for as much as actually making a 90-minute feature-length movie. What customers are also asking us a lot for, as they're using it more and more, is control and precision. How can they get their particular vision out onto the screen? And what we have realized, and through our research, is that control comes from intelligence, not just better prompts. You can't keep typing in again and again and actually do those things. So we have built a whole new model on top of Ray 3 called Ray 3 Modify that allows you to edit the world. So let me show you actually what that looks like. This won't have audio, and I'm going to tell you a little bit about what you're seeing. So what's playing on the screen is a demo of Ray 3's world editing capabilities. It can take any real or AI footage, so footage from cameras or footage that you generated, and change it as little or as much as you want to realize the creative goals. It's a powerful system that we have developed for our most ambitious customers who are most demanding, and they spread the gamut across entertainment, advertising, and this has allowed us to enable a new era of hybrid human-AI productions. The human becomes the prompt through motion, timing, and direction. You act it out, and then the model can produce it. What that means in practice is that filmmakers and creators can create entire cinematic universes, now without elaborate sets, and then edit and modify anything to get to the result they want. This has never been possible before. But in 2026, we are focused on actually going much further. 2026 will be the year of agents, where AI will be able to help you to accomplish more of the task, or hopefully the full end-to-end of the task, rather than doing some patchwork. So our teams have been working diligently building the world's most powerful multimodal agent models. Using Luma will suddenly feel like you have a large team of capable creatives who are working with you in your creative pursuit. We are building multimodal models, and actually these workloads are very complex compared to text models. One example of that is these consumes hundreds of times, thousands of times more tokens. A video that you saw, a 10-second video, is about 100,000 tokens easily. Compare that to a response from an LLM. It's about 200 to 300 tokens. So when we are working with this much information, TCO and inference economy is absolutely critical to our business. Otherwise, there's no way to serve all the demand that is coming our way. Through our collaboration with the AMD team, we have been able to achieve some of the best TCOs, total cost of ownership, that we have ever seen in our stack. And we believe as we build these more complex models that are able to do autoregressive diffusion and that are able to do text and image and audio and video all at the same time, this collaboration will allow us to significantly differentiate on cost and efficiency, which, as you know, in AI is a big deal. So through this collaboration, we have developed such a degree of confidence that in 2026, we are expanding our partnership to a tune of about 10 times what we have done before. And these 455 cards, and I cannot be more excited for MI455X because this, the rack scale solution and the memory and the infrastructure that you're building is essential for us to be able to build these world simulation models.
Well, we love hearing that, Amit. And look, our goal is to deliver you more powerful hardware.
The hybrid human AI video generation approach is compelling, has the potential to reduce the cost and complexity of special effects in production, although token costs remain high. Lisa then briefly discussed the MI500, AMD's next generation AI accelerator, before transitioning to the unveiling of new Ryzen AI PC processors and GPUs.
MI400 series was a major inflection point in terms of delivering leadership training across all workloads, inference, scientific computing, but we are not stopping there. Development of our next-gen MI500 series is already well underway. With MI500, we take another major leap in performance. It's built on our next-gen CDNA 6 architecture, manufactured on 2-nanometer process technology, and uses higher-speed HBM4E memory. And with the launch of MI500 in 2027, we're on track to deliver 1,000x increase in AI performance over the last 4 years, making more powerful AI accessible to all. So with that, thank you. So with that, now let's shift from the cloud to the devices that make AI more personal, PCs. So for decades, the PC has been about a powerful device helping us be more productive, whether at work or at school. But with AI, the PC has become not just a tool, but it's a powerful, essential part of our lives as an active partner. It learns how you work, and it adapts to your habits, and it can help you do things faster than you've ever expected, even when you're offline. AI PCs are starting to deliver real value across a wide range of everyday tasks, from content creation and productivity to intelligent personal assistants. Let's just take a look at a few of the AI PC applications today. Starting with content creation. These videos were created from simple text prompts on a Ryzen AI Max PC, so not in the cloud, but in a local environment. Anyone can generate professional quality photos and videos in minutes with no design expertise. Microsoft has been a key enabler of AI PCs, helping bring next-generation capabilities directly into our productivity tools. For example, managing your meetings, summarizing emails, quickly finding files that you need, using real-time translation on video conferences. And with Microsoft Copilot, advanced AI capabilities are being built directly into the Windows experience to complete tasks faster. You just describe what you need, and the PC takes it from there. Now, at AMD, we saw the AI PC wave early, and we invested. That's why we've led every inflection point. We were the first to integrate a dedicated on-chip AI engine in 2023, and the first to deliver Copilot Plus x86 PCs in 2024. And with Ryzen AI Max, we created the first single-chip x86 platform that could run a 200 billion parameter model locally. And now we're extending that leadership again with our next-gen Ryzen AI notebook and desktop processors. So today, I'm proud to announce the new Ryzen AI 400 series, the industry's broadest and most advanced family of AI PC processors. Ryzen AI 400 combines up to 12 high-performance Zen 5 CPU cores, 16 RDNA 3.5 GPU cores, our latest XDNA 2 NPU delivering up to 60 TOPS of AI compute, and support for faster memory speeds. These flagship Ryzen AI mobile processors deliver significantly faster content creation and multitasking performance compared to the competition. Now, there's a lot of excitement for the Ryzen AI 400 series, and if you're walking around CES this week, you're going to see many notebooks launching this week. The first Ryzen AI 400 series PCs begin shipping later this month, with more than 120 ultra-thin gaming and commercial PCs launching throughout the year from every major OEM across every AI PC form factor.
AMD continues to push AI NPUs into mainstream PCs. Local AI could become a significant market as the next segment demonstrated. For the consumer PC segment, Lisa brought Liquid AI CEO Ramin Hassani to the stage to discuss their efficient multi-model large language model optimized to run quickly on CPUs.
Ramin, it's great to have you here. I'm very excited about the work that you guys are doing at Liquid. You were really taking a different approach to models. Can you talk a little bit to the audience about what Liquid is doing and why it's different from others?
Absolutely, Lisa. It is great to be here We're a foundation model company, spun out of MIT 2.5 years ago. We're building efficient generative AI models that can run fast on any processor inside and outside of data centers. We designed from scratch multimodal models with a hardware-in-the-loop approach that allows us to optimize neural architectures for a given hardware. We are not building transformer models. We are building liquid foundation models. Powerful, fast, and processor-optimized generative models. The goal is to substantially reduce the computational cost of intelligence from first principles without sacrificing quality. That means liquid models deliver frontier model quality right on a device. Device could be a phone, could be a laptop, could be a robot, could be a coffee machine, and could be an airplane. Basically, anywhere compute exists with 3 value propositions: privacy, speed, and continuity. It can work seamlessly across online and offline workloads.
Ramin, our teams have been working really closely on bringing more capable models to AI PCs. Can you share a bit about that work?
Absolutely. Today, I've got 2 new product announcements. 1, we are excited to announce Liquid Foundation Models 2.5, the most advanced tiny class of models on the market. At only 1.2 billion parameters, the model performs best on instruction following capabilities between its class and models that are larger in its class. LFM 2.5 instances are the building blocks of reliable AI agents on any device. To put this in perspective for you, this model delivers instruction following capabilities better than the DeepSeek models and Gemini Pro kind of models, Gemini 2.5 Pro, right on the device. We are releasing 5 model instances: a chat model, an instruct model, a Japanese enhanced language model, a vision language model, and a lightweight audio model, audio language model, basically. These are highly optimized for AMD Ryzen AI CPUs, GPUs, and NPUs. And today, they're available for download on Hugging Face and on our own platform, Leap. There you can enjoy them.
That's pretty cool.
So we can stack these LFM 2.5 instances together to build agentic workflows. But then it would be really amazing if we can bring in all these modalities into one place. So that brings me to my second announcement, LFM 3. LFM 3, it is designed natively multimodal to process text, vision, and audio as input and deliver audio and text as an output in 10 different languages with sub-100 millisecond latency for audio-visual data. You will get LFM 3 later in the year.
All right, that's fantastic. So now, Ramin, help our audience understand, why should they be so excited about LFM 3? What can we do with these models on an AI PC?
Absolutely. So most assistants, AI assistants, co-pilots today are reactive agents. You open an app, then you ask a question, it responds. But when the AI is running fast on the device and is always on, it can be working, on the tasks proactively for you. The task can be done in the background. So let me show you a quick demo, a reference design to inspire what is possible to build on PCs with LFM instances. Let's jump in. Imagine you're a sales leader working on your AMD Ryzen laptop with LFM 3 backbone proactive agents activated. You're in full focus mode, working on a spreadsheet. Notifications start piling up. You get a calendar notification for a sales meeting, but want to continue your work in deep focus. A liquid proactive agent notices the meeting and offers to join on your behalf. You allow the agent to join, and while you focus on your data analysis task, in the background, the meeting is in progress with your agent representing you.
Are you sure we can trust this agent?
I think.
I'm a little worried there, Ramin.
This system can actually transcribe more than transcribing your systems, and really understanding what is going on. And the system can also be hooked up to your email platform. It can analyze your emails, as your emails are actually coming out. It can perform a deep research functionality. So with the deep research functionality, You can analyze every email and draft the response for you. Again, everything under your own control. You're not going to go, this is not going to go rogue. Everything is offline, locally on the device. So this system can deliver, a summary and can do the jobs better than what you have expected, what you have seen from reactive agents. I think this year is going to be the year of, proactive agents. And I'm very excited to announce that we're collaborating with Zoom to bring these features to the Zoom platform, actually.
That's fantastic. Ramin, we're really excited about what you're doing. I think you've just given people just a glimpse of what we can do when we bring, true AI capability to our PCs. So thank you. We're excited, and we look forward to all we're going to do together.
Thank you so much. Thank you for having me. Thank you.
Liquid AI's models can reportedly run on just 1 to 2.5 gigabytes of RAM, which is remarkable. That efficiency pairs well with AMD's Ryzen AI platform. Plan to test these models myself in the future. The unveiling of the AMD Ryzen AI Halo, similar to NVIDIA's DGX Spark, was another standout.
Today, I'm excited to announce the AMD Ryzen AI Halo, a new reference platform for local AI deployment. Now, I would say this is pretty beautiful. Do you guys agree? So let me tell you what it is. This is the smallest AI development system in the world, capable of running models with up to 200 billion parameters locally, not connected to anything. It's powered by our highest-end Ryzen AI Max processor with 128 gigabytes of high-speed unified memory that is shared by CPU, GPU, and NPU. This architecture accelerates system performance and makes it possible to efficiently run large AI models on a compact desktop PC that fits in your hand. Thank you. Halo supports multiple operating systems natively, ships with our latest ROCm software stack, comes preloaded with the leading open source developer tools, and runs hundreds of models out of the box. And this really gives developers everything you need to build, test, and deploy local agents and AI applications directly on the PC. Now, for all of you who are wondering, Halo is launching in the second quarter of this year, and we can't wait for folks to get their hands on them.
If it's cheaper than NVIDIA's DGX Spark, it could allow AI development to reach a greater number of people. I'm excited for its launch later this year. Dr. Fei-Fei Li, founder and CEO of World Labs, followed with a presentation on the Marble platform.
Consoles from Sony and Microsoft to deliver tens of billions of frames. And while the visual quality of those frames has advanced dramatically over the years, the way we build those worlds really hasn't. It still takes teams months or even years to bring a 3D experience to life. Now, AI is really starting to change that. To show what's next in 3D world creation, I'm honored to introduce one of the most influential figures in AI. Known as the godmother of AI, her work has transformed how machines see and understand the world. Please welcome the co-founder and CEO of World Labs, Dr. Fei-Fei Li. Fei-Fei, we are so excited to have you here. You've been one of the leaders shaping AI for decades. Can you just give us a little bit of your perspective? Where are we today, and why did you start World Labs?
Yeah, first of all, thank you, Lisa, for inviting me to be here. Congratulations to all the announcements. I can't wait to use some of them. So it's true that there has truly been great breakthroughs in AI progress in the past few years. And as you said, I've been around the block for a while, for more than 2 decades, and I really cannot be more excited than now by where things are going. So in the past few years, language-based intelligence in AI technology really has taken the world by storm. We're seeing the proliferation of all kinds of capabilities and applications. But the truth is, there's a lot more than just language intelligence. Even for us humans, there's more than passively looking at life in the world. We are incredible spatial intelligent animals, and we have profound capabilities that use our own spatial intelligence that connects perception with action. Think about all of you being here, how you braved through airports this morning. I'm one of them, or woke up in your hotel room and get to the nice coffee shop, or find your way in this maze in Vegas to be here. All this requires spatial intelligence.
I remember the first time I talked to you about your concept for World Labs and your passion about what this could bring. Tell us a little bit about what your models do so the audience gets a feel for what does this really mean?
Yeah, well, I heard that there are gamers out there, so this is very exciting. So traditionally, building 3D scenes requires laser scanners or calibrated cameras or hand-built models using pretty sophisticated and complicated software. But at World Labs, we're creating a new generation of models that can use the recent Gen AI technology to learn the structure, not only just flat pixel structure, I'm talking about 3D, 4D structure of the world directly from data, a lot of data. So give the model a few images, and even one image, the model itself can fill in the missing details, predicts what's behind objects, and generate rich, consistent, permanent, navigable 3D worlds. So what you're seeing here on screen is a Hobbit world that's created by our World Labs model called Marble. We just give it a handful of images, and it created these 3D scenes that are persistent, and you can navigate. You can even see a top view. And our system transformed a few visual inputs into a fully navigable, expansive 3D world. And it shows how these models not just reconstruct the environment, they really imagine cohesive worlds, wondrous worlds. And once these worlds exist, they flow together and allowing effortless transition from one environment to the next and scaling into something much larger. And this is much closer to how humans piece together a place from a few glances.
Well, it looks pretty amazing that you can do that with such little input. Now, can you just show us a little bit about how the technology works?
Yes, definitely. Let's just ground it in real world a bit more from the Hobbit world. Let's do something that you're very familiar with. So over the break, our team went to AMD's Silicon Valley office. I hope they got your permission. And
they did not, but that's okay.
Okay, well, now here we are. We just used some regular phone cameras. There's no special equipment, just phones to capture a few images. And then we put them into World Labs' a 3D generative model called Marble. And then our model that can use AMD's MI325X chip and the ROCm software stack can create a 3D version of that environment, including windows, doors, furniture, size, and sense of depth and scale. And keep in mind, you're not looking at photos, you're not looking at videos, you're looking at truly 3D consistent worlds. And then our team started to have a little more fun and decided to
You decided to remodel?
Exactly,
Yes, yeah.
for free for you. For different design styles, right? I don't know which one you guys like the most. I personally really like the Egyptian one, but maybe that's because I'm going there in a few months. And while this transformation is keeping the geometric consistency and the 3D inputs. So You can imagine this can be such powerful tools for many use cases, whether you're doing robotic simulation or game development or design. This can, what would traditionally take months to do in a typical workload, we really could do it in minutes now. And we can even navigate into an entirely different world, like actually the Venetian Hotel. And we just did that yesterday by taking a picture and then put it in the model and then had a little fun. And then it turned this whole place into a 3D imaginative space. And now I'm sure you guys can take pictures and send it to Marble and experience this yourself. But what you don't see here behind the scene is how much computation is happening and why inference speed really matters. The faster we can run these models, the more responsive the world becomes. Instant camera moves, instant edits, and a scene that stays coherent as you actually navigate and explore. And that's what's really important.
You know, Fei-Fei, I think you're going to have a few people going out to your website to try Marble this evening.
We'll keep the server up.
But look, that looked really amazing. Can you?
The ability to generate immersive 3D environments from images alone is a significant advancement. World Labs is another company worth watching, and Marble is already available to explore online. Lisa then hosted a panel of pharmaceutical executives to discuss AI and drug development.
So look, as you saw in that video, AMD technology is already at work across healthcare. This is one of the most meaningful applications. You've already heard about some of the stories tonight of how high-performance computing and AI is one of the areas that I am most personally passionate about, is how you can bring healthcare there. There's nothing more important in our lives than our health and the health of our loved ones. And using technology to improve healthcare outcomes means we measure progress in terms of lives saved. I'm very happy to be joined tonight by three experts who are leading the way in applying AI to real-world healthcare challenges. Please join me in welcoming Sean McLean, CEO of AppSci, Jacob Thaysen, CEO of Illumina, and Ulla Engquist, Head of Molecular AI at AstraZeneca. All right, guys, thank you so much for being here. You can see there's a lot of excitement about healthcare. Thank you for the tremendous partnership. You know, Sean, at AppSci, you're using generative models and synthetic biology to design new drugs from scratch. Can you walk through a little bit of how that works?
Yeah, thank you so much for having us here today. Biology is hard. It's complex. It's messy. Drug discovery and development is this archaic way of going about discovering drugs. Ultimately, it's this trial and error process where you ultimately are searching for a needle in the haystack. But with generative AI and what we're doing at AppSci, you're actually able to start creating that needle and being able to actually engineer in the biology that you want, being able to go after the diseases that have large unmet medical need, and being able to have the manufacturability, the developability that you want in the drug. We're actually able to start having precision engineering now because of AI with biology.
AI's role in healthcare innovation continues to expand, and it will be important to watch how the industry integrates large language models and AI systems into patient care and research. Next, Daniela Pucci of Generative Bionics presented the company's robotics work, including the Gene 1 robot.
Now, seeing is believing. So to show how some of this work is unlocking the next generation of robotics, please welcome CEO and co-founder of Generative Bionics, Daniela Pucci, to the stage. Hello, Danny. It's great to have you. your team is doing some amazing work. Can you just give us some background about what you're doing?
Lisa, Generative Bionics is the industrial spin-out of more than 20 years of research in physical AI and biomechanics at the Italian Institute of Technology. But when we look back, actually, everything started from a simple but profound question. If an artificial agent needs to understand the human world, doesn't it need a human-like body to experience it? To answer this, we built some of the most advanced humanoid platforms in the world. iCub for cognitive research, then ErgoCub for safe industrial collaboration, and then we built IronCub, the only jet-powered flying humanoid robot in the world. Throughout the process of building these robots, however, Lisa, there has been one belief that has never changed. The real working technology is that one that amplifies human potential, and that is built around people, not the other way around. Now, this belief has become the mission of Generative Bionics, but to make it real, we need compute that is fast, deterministic, and local. A humanoid, for instance, touch, balance, and safety loops cannot wait for the cloud. That's why our collaboration with AMD is so fundamental. AMD, in fact, gives us a unified continuum from embedded and edge platforms such as Ryzen AI Embedded and Versal AI Edge, running physical AI on the robot, to AMD CPUs and GPUs, powering simulation, training, and large-scale development. So, Lisa, one compute architecture from one partner end-to-end.
I like that. I like that a lot. Now, look.
Basically, that defines our DNA in terms of products, Gen 1. And I'm really happy to say that Gen 1 today has been ready to be released right now.
Is this gorgeous or what? Danny, tell us about Gen 1.
So, our vision is a future where humans remain at the center, supported by technology. That's why we focus on building humanoid robots that people can trust and accept. For us, acceptability means beauty, grace, and safety. Gen 1 is Italian by design.
Is it really Italian?
Yeah. But basically, what really sets Gen 1 apart is touch. A distributed tactile skin across the robot body allows Gen 1 to feel pressure, contact, and intention, making touch a primary source of intelligence. Just to give you examples why this is so important, in factories, touch makes possible basically to allow human-robot collaboration. And in healthcare, that is going to be pivotal. Basically, a patient can hold the robot and he can feel how to help the patient in the best way. So this enables safer decisions and more natural interaction in the real world, powered by AMD compute platforms.
It remains to be seen how human-like robots will scale in industrial settings, but the progress is notable. John Coleris of Blue Origin then discussed AMD's role as a technology partner.
Is Blue Origin. Please welcome John Coleris, Senior Vice President of Lunar Permanence at Blue Origin, to the stage.
Hi, Lisa.
John, thank you so much for being here. You know, Blue Origin is doing just some amazing things. Talk to us a little bit about your mission and what you're working on.
Yes, thank you everyone for having me here. I'm very excited to tell you about what we're doing. Jeff Bezos, our founder, likes to say that Earth is the best planet in the solar system. It sustained life for millions of years. And as we explore the solar system, Earth will be the origin of that life, that pale blue dot that is Earth. And that's why our company is named Blue Origin. To protect that planet, we want to move heavy industry eventually off the Earth. And that requires reliable, repeatable, low-cost operations and reliable and repeatable, low-cost equipment and vehicles. And AMD is a critical partner of ours to make that happen.
Well, thank you so much for that, John. And look, talk a little bit about why high-performance computing is so important in your work, and especially as your missions are getting more complicated.
Certainly. So space is the ultimate edge environment. The flight computers that we build are the heart and soul of our vehicles. That compute stack needs to be reliable, deterministic, and resilient. It needs to survive the environment of space. And what that means is we have mass constraints, power constraints, radiation considerations. And the AMD embedded architecture allows us to reduce mass, save power on these vehicles, and tolerate the demanding radiation environment of deep space.
AMD's embedded and high-performance computing products are supporting a wide range of aerospace and advanced engineering applications. Lisa then discussed AMD's role in scientific research, including the fastest supercomputers in the world. This led to Michael Kratios, Director of the White House Office of Science and Technology Policy, discussing the Genesis mission.
Today, AMD powers the 2 fastest supercomputers in the world and more than half of the 50 most energy-efficient systems. These systems are using massive amounts of compute to solve previously impossible problems. In Finland, the Luma supercomputer has cut climate model update times by more than 85%, enabling earlier warnings and better preparation for extreme weather events. Energy giant ENI is using an AMD-powered supercomputer to develop longer-lasting batteries and cleaner fuels. At Oak Ridge National Labs, the world's first exascale supercomputer is running Orbit 2, a hyper-resolution global model that allows us to predict unprecedented forecasting detail with nearly 99% accuracy. And at Lawrence Livermore National Labs, the world's fastest supercomputer, El Capitan, is modeling how viruses might mutate and evolve, enabling scientists to design more resilient antibody treatments and respond faster to future pandemics. Going forward, there's a lot more that we can do to power the future of scientific discovery. We are actually working very closely with the U.S. Department of Energy and America's national labs as part of the Genesis mission. Genesis is a national program launched late last year to accelerate the convergence of AI, supercomputing, and quantum computing. Together with Oak Ridge National Labs, we recently announced 2 new supercomputers that are part of the Genesis mission. The Lux computer, that is the first dedicated U.S. AI factory for science that will come online early this year, and Discovery, the next flagship supercomputer planned in 2028. Genesis is the most ambitious public-private technology initiative in decades. Leading this historic effort is Michael Kratios, who has shaped national policy at the highest levels as a former U.S. CTO and Undersecretary of Defense for Research and Engineering. Please join me in welcoming the President's Chief Science and Technology Policy Advisor, Michael Kratios, to the stage. Michael, thank you so much for being here. I know just how busy you are. You've described this Genesis mission as a real moonshot with the largest mobilization of federal scientific resources in decades. Can you talk a bit about why Genesis is so important?
The Genesis mission is a great example of how President Trump has moved fast in less than a year in order for the U.S. to lean in and win the AI race. Genesis is the largest marshaling of federal scientific resources in recent history, and at a scale and an urgency at the Apollo mission or even the Manhattan Project. We are bringing together the unmatched power of our national laboratories, supercomputers, and the nation's top scientific and innovative minds with the goal of doubling the productivity and impact of American science within a decade.
AMD continues to operate at the intersection of public and private sector scientific advancement. The final segment focused on AI and education. Lisa invited 3 students from a Hack Club team that won a nationwide hackathon.
Michael, look, we're incredibly proud to support the AI Education Pledge and really to help expand access to AI education with more hands-on opportunities for students to learn and build. That's why we've actually committed $150 million to programs that bring AI into more classrooms and communities across the country. We're investing in the next generation of AI research and talent. We're building research collaborations with more than 800 educational institutions around the world, including many of the top engineering and computer programs. And we're also committing to developing coursework to promote our open ecosystem. So we're offering free online AI courses to reach over 150,000 students this year. So, Michael, I want to say thank you for your leadership on this topic and the First Lady's leadership. I can tell you that it certainly is making a difference in galvanizing the industry. Now, before you go, I have a very fun thing for us to do. It is really a moment for us to highlight some really amazing work as a direct outcome of the AI Education Pledge. So, a little bit of background. We recently partnered with Hack Club on a nationwide AI and robotics campaign. More than 15,000 high school students signed up, with the top teams coming together in Silicon Valley last month for an in-person hackathon to bring their designs to life. It's actually incredible to see what these students were able to build in just one weekend. You can imagine it was a little bit competitive at this hackathon, and as part of the recognition, we invited the top 3 teams to be here at CES, right here in the front row, so they could experience the biggest tech event of the year firsthand, and we could congratulate them in person. So let's give them a big round of applause. And to tell us a little bit more about their project, I'd like to invite the hackathon gold medal winners, Emmy McDonald, Ruzana Gaboyan, and Afia Ava of Team Arm Tender to the stage. All right, you guys are amazing. Congratulations on the incredible work. Now, before you talk about the project, can you just share a little bit about yourselves, like where are you from and when did you start coding?
Sure. I'm Emmy, I'm 17, and I'm from Chapel Hill, North Carolina. I started coding when I was around 12, and I joined Hack Club when I was 16. Good evening, everyone. It's great to see you all. My name is Ruzana Gaboyan, and I'm a 17-year-old student from Cleveland, Ohio. I started coding when I was 12, and I joined Hack Club as soon as I turned 16.
Hi, everyone. My name is Afia. I'm 18 from Beaver Dam, Wisconsin. I started coding about 2 years ago through Hack Club.
That is fantastic. Now, tell us a little bit about your project.
Of course. Together with Ruzana and Afia, my Hack Club teammates, we built an AI robot barista. It's a robotic arm that autonomously serves beverages using a motorized wheel that spins to select a soft drink. We trained a single unified vision language model to multitask using the AMD Developer Cloud with MI500X GPUs. The robotic arm runs entirely on an AMD Ryzen AI laptop using 3 cameras. And we came to the hackathon with no previous AI training experience.
Now, can you believe that? No previous AI training experience, and this is what they did? You guys are clearly doing great things. Just give me an idea, like, what are you most excited about working on next?
Thanks so much, Lisa. So my mom actually works at our local fire department. She's in the audience. Hi, Mom. And she is a former firefighter. One thing that we noticed when training Arm Tender is that it was able to capture complex human behaviors. Like, it was able to try again to grab a can after it missed it without us programming that specifically. I want to build a robot that can be used in firefighting to go into building fires and case the building before firefighters go in. And the complexity of motion that we saw AI exhibiting could make that possible in a way that wasn't before.
I love that. What do you guys think? Well, look, we are all about encouraging and inspiring young people to pursue their dreams. And tonight, we actually have a special surprise for you guys. So AMD is awarding each of you a $20,000 educational grant to invest in your future as innovators to help you keep building.
Thank you so much. Thank you so much.
Look, you guys are just a great example of what the AI Education Pledge is all about, because what you've created, it's clear that there's so much we can do. So congratulations to all of you. And Michael, thank you for being here and really helping bridge all of this together. We appreciate everything you're doing for the country and for the industry. Thank you so much.
Thank you, guys. Congratulations.
Congratulations to the Arm Tender team for winning a $20,000 educational grant from AMD. Also, firefighting robot is a great idea.
This moment in tech not only feels different, AI is different. AI is the most powerful technology that has ever been created, and it can be everywhere for everyone. We're entering this era of yard-scale computing, where the deployment of more powerful models everywhere will require a massive increase in the amount of compute in the world. Meeting that demand will take a broad portfolio of solutions, from the largest systems in the cloud to AI PCs to embedded computing. And just as important, it takes an open ecosystem built on industry standards. That's what you saw on stage tonight. We wanted to bring you the entire spectrum, from amazing technology to deep co-innovation with industry leaders across the ecosystem, to very strong public-private partnerships. All of us are working together to bring AI everywhere for everyone. On behalf of the 30,000 AMDers around the world, we're proud to be building the future together with all of you, because the world's most important challenges can only be solved by bringing the industry ecosystem together. Thank you for joining us tonight, and enjoy the rest of CES 2026.
That's a wrap on my long day. Exhausted but thrilled. As I was exiting the ballroom, I was definitely feeling a little sleepy. Looking back, AMD demonstrated a broad and competitive product lineup positioned to gain share in the AI computing market. The central question remains whether its open infrastructure and software ecosystem can gain comparable developer adoption to NVIDIA's widely used CUDA platform. In my next video, I'll cover CES Day 2 and the Siemens keynote with NVIDIA. Stay tuned to the NavFile YouTube channel for that coverage. If you found this video to be helpful, please like it and subscribe. You could also follow me on LinkedIn, X, Instagram, or Facebook. Just search for my name or visit davidaug.com. I'll see you in the next video.